Hello everyone. I welcome everyone for the course Manipulated Robotics Theory course. Today's topic is Jacobian, or I can say Manipulator Jacobian. So, what is Manipulator Jacobian? For a robot manipulator, for a robot manipulator with end of end of end of means degree of freedom. So, for a robot manipulator with end of, so manipulator Jacobian is manipulator Jacobian is a mathematical tool. It's a mathematical tool whose matrix is in the order of. It's a tool and it's a matrix. So its order is 6 cross n. N represents degree of freedom. Okay. So it's 6 cross n matrix. So that relates the end effector velocity. End effector velocity. Okay. End effector velocity and joint velocity. Joint velocity in the following. Okay. So what is manipulator manipulator Jacobian? For a manipulator with the n degree of freedom, so it is defined as it is a mathematical tool whose matrix is 6 cross n that relates end effector velocity and the joint velocity in the following manner. Okay, so here end effector velocity is in this side. So it is x dot. X dot means linear velocity in x direction, linear velocity in y direction, linear velocity in z direction, and angular velocity in x direction, angular velocity in y direction, angular velocity in z direction. That is why it has got the number 6. Okay, n is dependent on the number of degree of freedom. So that is equivalent to Jacobian into q dot. Okay, so this q dot is theta dot for revolute joint and d dot or any variable that is for prismatic joint. So manipulator Jacobian means that is a mathematical tool whose matrix is 6 cross n. So this is 6 cross n, and then this one is 6 cross 1, and then uh, q dot is it is n cross 1. Okay, n cross 1. So that when you multiply, you will get 6 cross 1. So n cross 1 is degree of freedom. So in this way, it is related. Okay. So we'll see. We'll see some more introduction in this, and we'll do one problem here. Okay. So next. So here, this left hand side, this is end effector denotes the the left hand side end effector velocity denotes the linear velocity as well as angular velocity. Okay. So, see, mainly we are going for robot for doing a particular job. Okay. So I have to move the manipulator to do a painting on this way. Okay. So this is my second point. So here my end effector should move on this path to do a particular job. Okay, suppose if you keep a tool on it, so it will drill it, along the path. Okay, so this is A point, this is B point. So we have to make the manipulator to traverse along the path with the velocity. So that velocity is called as end effector velocity. Okay. So at every point, your velocity, so every point you have that velocity. So that velocity is in this form: x dot, y dot, z dot, and omega x, omega y, omega. So, but every point you can experience this velocity. Okay. So to find out this velocity, we need, or the user is in need of q dot. Q dot means joint velocity. When you give the joint velocity, automatically the manipulator takes up the end effector velocity. So for that, everyone should know Jacobian. So if you know the Jacobian, it is easier to find out because you know the Jacobian and we have this required end effector velocity. Automatically, we will find out the joint velocity. Okay, so I can say that. So here, some mapping. Okay, so this is joint space, and then this is Cartesian space. This is actuator space. Okay, So first, the user, here the user says, I need this kind of velocity. Okay, so that velocity is given as a control input to the actuator. So as the result, so that actuator when actuator joins. So as a result, it will give joint velocity. Then that joint velocity is given, I mean, that is converted into a end effector velocity, x dot, y dot, like that. Okay, so this is the mapping. Okay, so let's move to the problem. So the first problem we are going to see is RR manipulator. So let's see RR manipulator. So we are going to calculate the Jacobian for RR manipulator. So Jacobian is termed as JI because I have two joint. So for I represents 1 to N. Okay, this is I. So here you have RR manipulator. So the formula is J1 and J2. So what is the formula? Actually, we have two joint, revolute joint and the prismatic joint. So if it is prismatic joint, then the Jacobian will be position vector of I minus 1, 0. Okay, so this is my, Ji for prismatic joint. Okay, the top one is always linear velocity. Okay, so this one is angular velocity. So for the prismatic joint, you will not have angular velocity, you will have only linear velocity. So the linear velocity formula is position vector I minus 1 for Ji. Okay. Whereas for revolute joint, the Jacobian is P I minus 1 cross because they are perpendicular to each other. That is by cross product. So P N I minus 1. Okay. And then here P I minus 1. So in this gives the linear velocity, this gives the angular velocity. So definitely in revolute joint, you will have angular velocity. As the result of angular velocity, you will have some displacement or you will have some movement. So that is linear velocity. Okay. So this is the Jacobian for revolute manipulator or revolute joint. This is the Jacobian equation for the prismatic joint. Okay. So let's continue. So RR manipulator. So in this we have J1. Both are revolute joint only. So the formula is, so once again I'll write. Ji is equivalent to Pi minus 1 cross product Pn I minus 1 and then Pi minus 1. Okay. So let's apply J1, which means I equal to 1. So I equal to 1, if you apply over here, I minus 1 becomes P naught cross product. Then N is the degree of freedom is 2, then I minus 1 is P. So P2 naught. Okay. Then next one is P naught. So this is my J1. And then J2 is, so now I becomes 2. So 2 minus 1 is P1. Cross product Pn is 2. 2 minus 1 is 1. And then P1. So we have to calculate this. Okay, so let's see the formula. For example, if Pi minus 1 means, so it is just a rotation matrix or I minus 1 with respect to the base, and then you have to multiply by one unit vector. So this is my Pi minus 1. Okay. Then what if Pn I minus 1? Okay, for that, let me say one simple logic. So here you have the base. Okay. Then you have some joint. So this are link. Okay. This are link. Then likewise it proceeds and you have one link and this is last one. Okay. Actually, we have a gap in between because it involves lots of joints. So this is my gripper. So let me say this is my base joint, and then, for example, this is my I minus 1. This is my which means link I minus 1, link I, and then link I plus 1. Likewise, it goes on. Then finally, I have here nth frame. Okay. Okay. So now I want to represent. Okay. I want to represent this n with respect to O. So which is position vector, then nth frame with respect to O frame. Okay. Okay. Then I want to represent this guy. Okay. So this guy is position vector of nth frame with respect to I minus 1. And then I want to represent this guy. Okay. So this guy is P I minus 1 with respect to 0. Okay. So let's apply the vector addition. So it is Pn0 is equivalent to this and this. Okay. So it is Pi minus 1 0 plus Pn I minus 1. Okay. So in this I want Pn I minus 1. So what is Pn I minus 1? Pn0 minus Pi minus 1 0. Okay, so this is the formula. So in this, how do I get this? So for see, since it is with respect to the different frame, so I need transformation matrix. So transformation matrix of the nth frame with respect to 0th frame. Then I want the position vector. So if I want to get the position vector alone means then the transformation matrix should be multiplied by one unit vector. Okay, so that vector is in the order of nth order one. Okay, minus then again this Ti minus 1 0. Since I want only the position vector, so that has to be multiplied by the n vector. So this is the formula. So what is Pn I minus 1? It is Pn 0 On minus Ti minus 1 0 On. Okay. So let's calculate this. Okay. So let me use okay. So now what do we want? P naught. Okay. So what is the formula for P naught? So supply, I mean, a substitute over here. So R naught 0, I mean, I vector. Okay. Then what is P1? P1 is R1. Okay. Because P1 is R1 only because this the same thing should appear here. R1 0, I vector. Okay. Then that's all. Then I have to give P2 0. Okay. So let's use this. So P2 0. So what is P2 0? The formula is T2 0 because T2 0, the same thing would appear over here. And then O2 minus Ti minus 1. So Ti minus 1 the same thing. So 0, 0, O. Okay. So similarly, we want one more parameter which is P21. So P21 is just substitute. So Tn0 On, there is no difference, minus Pi minus, Ti minus 1. So Ti minus 1 means, so here, actually, yes, Tn0, sorry, I'll put, then I have to put 2 only. Sorry about that. So P2 0 is equivalent to T2 0 O2 minus then Ti minus 1. So Ti minus 1 here is, so here we are going to calculate T to 1. Okay. So T to 1. So it is T10 O2. Okay, that's all. So these are the formulas. So I have given the formulas. Straight away, we'll apply these formulas in the equation. Okay. So in this, what did we learn? So what is J1 and J2? And then how to get the position vectors with respect to that particular frame. Here also with respect to the end frame with respect to the base frame or the previous frame. So for that, this is the formula. And to get the position vector, we have to multiply the transformation matrix with the unit vector. So automatically you will get the position vector. So this is the formula. So T20 O2 minus T naught this. And for P2, so T20 O2 minus T1 0. Okay. So let's do the problem for manipulator. Okay, so RR manipulator. Okay, so for our RR manipulator, so you should remember this. So T10 is already we have done many a times. So let me write this C1 minus S1 0 L1 L1 C1. Okay, then S1 C1 0 L1 S1. Then 0 0 1 0 0 0 0 1. Okay, so next one is T2 1. T2 1 is C2. So this is okay. C2 minus S2 0 L2 C2. Then S2 C2 0 L2 S2 and 0 0 1 0 and then 0 0 0 1. Okay, so this is one matrix. Then T2 0. Okay, so you have to multiply. So how did you get T2 0? T21 should be multiplied with T10. Okay. So once you multiply, you will get C12, S12 0, L1 C1 plus L2 C12. Then S12 minus C12 equal to L1 S1 plus L2 S12. Then here 0 0 1 0 0 0 1. Okay. So this is C12 means cos of theta 1 plus theta 2. Sin 12 means sin of theta 1 plus theta 2. Then L1 is the link. This one is cos theta 1. So these are the transformation matrix we will require. Okay. So first let's do J1. So we know that the J1 formula is P naught cross product P 20 and P naught. Okay. So what is P naught? P naught equal to R naught naught into unit vector. So R naught means there is no rotation. So which means the matrix is in identity matrix only. So 0 0 1 that should be multiplied by 0 0 1. Okay. So the answer is 0 0 1 only. 0 0 1. Okay. So next we have this then P20. Okay. So what is the formula for P20? T20 O2 minus T10. Okay, T1, sorry, this I minus 1, so T naught to this and O2. Okay, so what is T20? So this one, this is T20. In this, if you see T20 and then 0 0 0 1. Okay, so here T20 0 0 0 1. Okay, so if you multiply this with this O1 means you will get the last column. That is why we have done this. Okay. So if you multiply, simpler. See, suppose if you take some 1 0 1 2 1 6 0 1 3. Okay. So this is multiplied by 0 0 1 means you can check the answer. So multiply, you will get 1 and then here it is 6. So you will get 6. See, if you multiply this, you will get this one. Okay, similarly, if I want to get the last one, because in a transformation matrix, the last column is the translation part. So this is the translation part. So I want to translation means it is a position vector. Okay. So I want to get this, so I have to multiply this. So once we multiply, I will get the answer like P20 is this for this one it is L1 C1 L1 C1 plus L2 C12. Then L1 S1 plus L2 S12. Then 0, 1. Okay. Similarly, when you multiply this, you will get the last element 0, 0, 0, 1. Okay. When you subtract, what is the answer? L1 C1 plus L2 C12. Then L1 S1 plus L2 S12, then 0 minus 0 is 1, I mean 0, 1 minus 0 is 0, okay. So now we have got everything. So now we have to put it in the order, okay. For that, first we have to calculate the cross product. So I have to calculate the cross product. So now I'll put that. So J1 is equivalent to, first one is P naught, okay. This one, cross product. So it is L1 C1 plus L2 C12, L1 S1 plus L2 S12 and 0. Okay. And then here you have 0, 0, 1. So this is my Jacobian. Let's simplify. So cross product is, so first you have to hide this, you have to multiply, that will be 0, then hide this, then you're in this, actually you have to hide this, okay, for cross multiplication. Then this 0 into 0 minus this. So I will get minus L1 S1 minus L1, sorry, L2 S1. Okay, so for this, for the second row, I have to hide this. Okay, so you can put this one minus this. So that will also be, okay, so for this. So that is L1 C1 plus L2 C1. Okay, so the cross multiply we have studied already, so we have to hide this. then you can multiply this minus this, okay, this one. Then for the next one, it is 0, okay. So now we have got the J1. So Jacobian J1 is equivalent to minus L1 S1 minus L2 S12 and L1 C1 plus L2 C12 is 0 and this is 0, 0, 1. That's all. Jacobian is done. Jacobian 1 is done. Okay. So now let's move to Jacobian J2. So what is the formula for J2? The formula is P1 cross P21 already we have defined and then P1. Okay. So let's do P1. So what is P1? R10 into this I vector. So what is R10? Already we know that R1 is C1 minus S10, L1 C1, then S1 C10, L1 S1, then 0010, 0001. Okay. In this, your R is this. This is my R. This is called as R10 because T10 is this. So this is called as R10. So that should be multiplied by what is that? So C1 minus S10, S1 C10, 001. So this should be multiplied by unit vector. So what is the answer you will get? 001. Okay. So this is my P10. Okay. So next one is I need to calculate P20. Okay. So P20 formula is sorry, P21. Okay. So P21 formula is T20O0 minus T10 O2. Okay. So already we have found this in the previous class, I mean the previous slides. So it is L1 C1 plus L1 C12, then L1 S1 plus L2 S12, then it is 0, 1. Okay, already we have defined. And then this will all, this one, T10 means this is T10. If you multiply by O2, you will get the last column. So what is the last column? L1 C1, L1 S1 and 0 and 1. Okay. Then if you subtract this, so this one, this term will be cancelled. So you will have L2 C12. And then if you subtract this, you will have L2 S12. Then 0 and 0. Okay. So this is my P20. Now I have to do the cross multiplication. So what is J2? J2 is P1 cross multiplication, P21 and P1. Okay. So we have derived P1 as 001, then cross product L2 C12, L2 S12 and 0. Okay. So here 001. Okay, so let me do the cross multiplication. For the first one, hide this, then 0 minus, so it is minus L2 S12. And then for the second one, hide this, then cross multiply, it is L2 C12. And for others, it is 0, then you have to write the remaining one. Okay, so that's all. J2 is done. Now we have to combine this J1, J2. So already we have derived what is J1 minus L1 S1 minus L2 S12 and then L1 C1 plus L2 C12 then 0 0 0 1. Okay, for this one L2 S12 L2 C12 0 0 0 1. That's all. So we can see the J matrix is 6 cross 2 because the formula is 6 cross n. N here is 2 degree of freedom. Okay. So that's all about Jacobian. So in this we have seen what is manipulator Jacobian. It relates end effector velocity with the joint velocity. So to under the user is always interested in knowing the joint velocity. For that we have to derive this. So the Jacobian for prismatic and rotary joint is given. Anyway, the Jacobian comprises of the top portion is linear velocity, then the bottom portion is angular velocity. Okay. Then it is the position vector only. Just you have to take the position vector and you have to do the, I mean, this I mean, cross multiplication, or you have to take the position vector and arrange it, then that gives the Jacobian. Okay. Thanks for watching. That's all for today.